We're going to do an acid-base titration problem. This is from Unit 4 of the workbook, number 13. Acid-base titration problems are nothing more than stoichiometry problems, similar to what we did in the last course. The only difference is that they're applied and they're always in the same context. So we're going to look at two different ways to do this problem. The three-step method like we used in Chem 1120, and a shortcut that uses a formula. So the question reads, a 25 milliliter sample of sodium carbonate requires an average volume of 12.96 milliliters of nitric acid to turn bromothymol blue from blue to yellow. If the concentration of the nitric acid is known to be 0.1009 moles per liter, determine the concentration of the sodium carbonate. So you'll notice we have the reaction of an acid with a base. We need to write an equation which represents this reaction. No matter which method we choose, we need to understand it and understand the reaction. So first, Na2CO3 reacts with nitric acid. And you should be able to predict the products. We end up with sodium nitrate and H2CO3. Now we know that the reaction needs to be balanced, so I can balance the reaction. And we also know that the H2CO3 that's produced is actually H2O and CO2. But that doesn't really matter here because the only part that's important is the stoichiometric coefficient of the acid and the base. I'll write my given information in. I know that the volume of the nitric acid is 12.96 milliliters, that its concentration or molarity is 0.1009 mole per liter or molar, and that the volume of the base, the sodium carbonate, is 25.00 milliliters. Whichever I have two pieces of information in my three-step stoichiometry method, whichever I have two pieces of information about, I will use that to figure out a number of moles. So the number of moles of HNO3 is equal to C times V. Now, if you wish, you can change the volume here to liters, but if you do a unit conversion here, you'll see you'll only end up doing another one later on. There's really no need. Most of the time, engineers, when they do this calculation, they'll leave the unit milliliters in place. So I'll show you what to do with that. Molar is moles per liter. So when we multiply these two numbers directly, we get 1.308, and we'll keep the unrounded value in the calculator. And if liters cancel, I'm left with the prefix milli and the unit mole. So 1.308 millimoles. The next step is to figure out the number of moles of my unknown substance from this one. So the number of moles of Na2CO3 is the number of moles of nitric acid times the mole ratio required over given. 0.6538 millimoles. Now, if I have a volume and a number of moles, I can figure out the concentration or molarity of my unknown base. The concentration of the Na2CO3 is its number of moles divided by its volume, 0.6538 millimoles, and divided by the volume, 25.00 milliliters. So you see I have a second volume here, and I would have been doing a second unit conversion, or by leaving milli, they just cancel at this step. So I end up with a concentration of 0.02615 moles per liter, which can also be written as 0.02615 molar. So this formula is on your data booklet. It says B MAVA equals A MB VB. The stoichiometric coefficient of the base times the molarity of the acid and the volume of the acid is equal to the stoichiometric coefficient of the acid times the molarity of the base times the volume of the base. This formula is affectionately known as the gym teacher formula. So the story is that the gym teacher was assigned to teach chemistry, and being much smarter than everyone else, the gym teacher came up with a one-step method for doing titration problems. Don't forget, your gym teacher probably did anatomy and physiology with the School of Medicine and may be the smartest faculty member in your school. In this case, we still need the balanced equation, and we need to understand what everything is and where it belongs. So I still need to write a complete balanced equation because I'm going to need these coefficients, and I need to organize the information and to know what everything is. So in this case, it is the concentration or molarity of the base that I'm looking for. And I want to solve for MB. So MB is equal to B MA VA over A VB. Gym teacher was pretty good at math too. So the coefficient of the base is 1. The molarity of the acid is 0.1009 molar. The volume of the acid is 12.96 milliliters. The coefficient of the acid is 2, and the volume of the base is 25.00 milliliters. As long as you know what everything is and where it belongs in this equation and you're good at math, the beauty of this equation is that you don't have to do unit conversions as long as your volumes are in the same unit and your molarities are in the same unit. Everything simply cancels. Of course, remember that you're bracketing the bottom or dividing by the 2 and the 25, or else your math won't work out here. So in one step, we get 0.02615 molar to 4 sig figs. One and done. But you put all your eggs in the one basket, and if you make any mistakes, you got it all wrong. So if you're going to use the gym teacher method, you better make sure that you understand your stoichiometry problem and that you practice so that you know where everything goes, and then you'll be just as clever as the gym teacher.